রেকর্ডিং স্টার্ট হচ্ছে। তোমরা তোমরা রেকর্ডিং স্টার্ট হয়ে গেলে তোমরা তোমাদের নাম আর রোল নাম্বার পাঠিয়ে দিও। Okay, today I shall start envelope, sorry, asymptotes. Okay, asymptotes. So let me write it, asymptotes. Someone has entered. Okay, so asymptotes. Asymptotes. Asymptotes are state lines. First of all, asymptotes are state lines. Remember this fact. Okay.
স্যার,
হ্যাঁ বলো।
স্ক্রিন দেখা যাচ্ছে না।
হ্যাঁ দেখা যাবে না, আমি এমনি আগে বলে নিচ্ছি তারপর। Asymptotes are state line. So don't confuse with it with the curve, but asymptotes of a straight line is not possible. So asymptotes of curve is there, so we shall consider asymptotes of the curve. Now the general equation of a curve is a nth order equation like this. You see, nth order equation like this one, equation for algebraic curve. Okay, this is called algebraic curve. Now Pn is plus Pn minus 1 plus Pn minus 2 plus any equation of curve, say any fx, and we are writing equation of the curves in this form. Okay, so it is a function of x. Now this function of x can be written in a algebraic form, in any form. Okay, but every equation can be converted to this form, where Pn is like, someone has entered. Okay, Pn is like, looks like this: a0 y to the power n plus a1 y to the power n minus 1 into x plus a2 y to the power n minus 2 into x square plus dot dot dot, this type of. Okay, similarly you can write down Pn minus 1, so it will start from Pn minus 1 with this. These are constants, that is coefficients, with this say b0, b1 and so on. Okay, so each term has some expressions like this. So this is the general equation of nth degree, and this is called the equation of an algebraic curve. Okay, now we take x to the power n common, so this becomes like this. Check it. Okay, and this function can be written as phi n y is a function of y by x. So this is our this is a notational convenience. Okay, so this equation for Pn, if you substitute this one, so this equation come into play like this: x to the power n phi n y by x plus second one will be x to the power n minus 1, so let it represent by phi n minus 1, and that will be also a function. But here and here these constants may be different. Okay, there is no restriction on it number. Then x to the power n minus 2 phi n minus 2 y by x. okay, plus dot dot dot, and this is equals to 0. So this we can convert it in this form. Okay, now as I told you that this is the equation of the curve, and any asymptotes of this curve will be a straight line. So a straight line has the form y is equal to mx plus c. So if we know m and if we know c, then we know that straight line, is not it? This is the equation of the straight line and this is the equation of the curve. So here we like to find out that asymptotes, that straight lines which are asymptotes to these curves. Now meaning of the asymptotes is that it will touch the curve at infinity. It will touch the curve at infinity. That is the characteristics of the asymptotes. Understood? So characteristics of the asymptotes is that it will touch the curve at infinity. So that means touch the curve means as, so this can be written as at infinity means at x is equal to infinity. So if we divide it by, remember this fact that the asymptotes are called those straight lines which will touch the curve at infinity, at x is equal to infinity. So we shall derive this some expression for asymptotes under this condition. Okay, so divide this expression by x to the power n. So what will happen? Phi n y by x plus 1 by x phi n minus 1 y by x plus 1 by x square phi n minus 2 y by x, okay, dot 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 equals to 0. Now if we take modulus x tends to infinity, that is taking the limit, you can write it, taking the limit mod x tends to infinity, okay. So and y by x tends to m. M is the slope of the curve, okay. So now see, if x, so from here you check it, y by x is equal to m plus c, okay. Now this limit, if limit x tends to infinity y by x becomes m provided c goes to 0. So if this limit exists and equal to m, so these two conditions must be satisfied to be for a asymptote. So we take x tends to infinity and y by x tends to m, so that, so y by x is equal to m, so the equation becomes phi n m plus this becomes x tends to 0, so this becomes 0, this becomes 0, and all the other terms dot 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 becomes, due to this x term in the denominator, it will become 0. So 0 plus 0 plus dot 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 dot, dot equals to 0. So what we will get next page, let me go to the next page. So we ultimately get, taking this limit as modulus x tends to infinity and y by x tends to m, we get phi n m equals to 0. Okay. Now this means this is an equation of nth degree and argument m. Okay. So, and this side is equals to 0. That means what does it mean? You know from your knowledge of algebra that phi m implies phi m n m is nothing but some constant a0 into m minus m1 into m minus m2 and so on, m minus mn. Okay, that means there are a n number of roots of this equation, and m1 m2 m3 m4, all these are roots of this equation. Okay, so phi n y by x is equal to a0 y by x minus m1 y by x minus m2 dot 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 y by x minus mn. Okay, so these are values of m1 m2 m3 will be getting. Okay, this implies, where from we have got it? We have got it for p n. So this is nothing but y a0 into y minus, y minus m1x y minus m2x y minus mnx. Okay. And here we can not a0, we can from here 1x, from here 1x, from here 1x, so x to the power n taken common. Okay, so phi nx is like this. Okay, hence each factor, so we can write down that each factor, hence we can write down, hence each factor of the, this is very important line, highest HIGHEST, highest degree term in Pn equating to 0 gives a straight line, through the origin. Okay, parallel to an asymptote, that is y minus m1x equals to 0. Passing through the origin means c1, c becomes 0. Okay, so you have got this one. Okay, then y minus m2x equals to 0, and so on, y minus m3x equals to 0, and so on, y minus mnx equals to 0. Okay, let so this condition we are getting now. Pnx is equal to, so this is our, now why this highest degree term? In any equation, algebraic equation, you will get this highest degree term, and your first work will be to make the highest degree term equals to 0. That is, this is the cause. I will tell you. Now let our asymptotes to this curve, okay, to this curve, these are straight lines. We call these straight lines as asymptotes, but these are asymptotes. These are asymptotes parallel to the asymptote. These are straight lines parallel to the asymptotes. These, okay, understood? These are straight lines parallel to the asymptotes passing through the origin. But our asymptotes may not pass through the origin, so let y minus y is equal to m1x plus c1 be our origin, be our asymptotes to the curve. These are asymptotes parallel to the straight line, this, or say they are asymptotes parallel to the straight lines, this, they are passing through the origin. Understood? But we are not concerned about the asymptotes straight line parallel to the asymptotes passing through the origin. We want the original passing asymptotes. Let that asymptotes be y is equal to m1x plus c1, then y is equal to m2x plus c2, and so on, y is equal to mnx plus cn. Okay, now there are two cases. Okay, let me take the page. Case 1. Okay, let y minus m1x be a non-repetitive that means non-repetitive factor of Pn. What does that mean? Okay, let me go to the previous paper. So Pn is this. Non-repetitive means m1, m2, m3. There are maybe say m2 and m5 equal. So in that case, m2 and m5 equal. In that case, this factor will be repetitive. Say in this case, let that it is a non-repetitive factor. That means this factor is non-repetitive. Okay, that means no one of m2 mn is equal to m1. Understood? So this can be written as, so our whole equation of the curve can be written as y minus m1x, since this is first term, so it is q n minus 1 plus, say, rest term, say whole of the rest term has been written as f n minus 1, that is equal to 0. So q of the rest term is means, okay, let me go to the previous page here. So this function and this part taken together has been written as q this part. Okay, and this term is the other terms where here. Okay, for Pn minus 1, Pn minus 2, so these are other terms, next term. So this one, where Pn is equal to, where Pn is equal to y minus m1x q n minus 1 and f n minus 1 is equal to p n minus 1 plus p n minus 2 plus dot 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 so on, rest terms. Okay, so this implies C1 is equal to limit x tends to infinity y minus m1x, okay, and that is equal to limit x tends to infinity minus f n minus 1 divided by q n minus 1 from this equation. Okay, now this limit can be this limit is finite because degree of f n minus 1 is not greater than that of q n minus 1. Okay, so this is a finite term because there is no term like this 1 by x or so on, because of this fact degree of fn minus 1 is not greater than this term. Okay, so there will be no term like this 1 by x, so this term will not be 1 by this term is greater than degree of this term is greater than this term, so there will be no term like x or x square or like this, so that the whole limit goes to the infinity. So it may go to the 0 or it may go be some finite number. Okay, have you understood this one? This degree of this term is not greater than this term. Okay, if it is greater, then x into or x square or x cube or something power to the power x will appear in the numerator, and x tends to infinity, so numerator will go to the infinity. Okay, that means this term, this is not greater than that of this, that's why this limit will be a finite limit, so we are getting C1. Okay, similarly we can get C2, similarly we can get Cn. Okay, so this is the rest of the term divided by the coefficient of the y1 minus mx. Okay, remember this fact. So this is our for C1, so this is one equation, and the y minus m1, that is another equation. So we are getting the C1, and we are getting, you have already get this m1. Okay, so this is our case 1. If this is, there is no repetitive factor. Okay, next thing is that case 2. Case 2, let sum of the factors of the highest degree term Pn be repeated. Okay, so let y minus m1x is the repeated factor, okay, in Pn. So this Pn is the repeated repeated factor. Let the repetition is like this. Say Pn is equal to y minus m1x. Say it has been 2 into q n minus 2. Why it is n minus 2? I think you have understood it. Okay, the two terms has been taken common, so qn minus 2. In this case, we let Pn minus 1 contains y minus m1x as a factor. Okay, let Pn minus 1 is equal to y minus m1x into f n minus 2. Okay, sorry, q, not f, q. Q n minus 2. Pn minus 1. Okay, you can write it qn minus 2. F n minus 2 also you can write, because Pn minus 1 is with, okay, I am showing you the previous pages also from where I have written it. Okay, check it. Suppose this term, okay, let me go to here, check it here. Okay, this term contains y1 minus x, y minus m1x, and say this term also. Okay, so this term will contain f n minus 2 and this term will contain q n minus 2. Is that clear? Okay, here also you can see. Next, so f n minus 2 and q n minus 2 is clear. Suppose Pn, then the given our equation looks like this: y minus m1x whole square q n minus 2 plus y minus m1x into f n minus 2, that is equal to plus some remainder term. Okay, now these two terms are homogeneous. Homogeneous means all of you know that qn minus 2 starts from the highest degree in x and then go on gradually the lower degrees without missing any in between terms. So these two terms are homogeneous. Okay, and their degree is n minus 2 and r n minus 2 is at most degree n minus 2. Okay, so let so this is of, you can write down, this is of n minus 2 degree, these are homogeneous in n minus 2 degree, and these are at most n minus 2. It cannot be more than n minus 2 degree term. Okay, so y is equal to m1x plus c1 be an asymptote of the curve. Okay, so c1 is equal to limit x or mod x tends to infinity y minus m1x, this one. Okay, and here y by x tends to m1 also. Okay, so these two limit you have to check here. Okay, taking limit as, that means, this means first you take the limit as y tends to infinity and then y by x tends to m1. Okay, so this equation then becomes c1 square, this equation. Okay, c1 square plus c1 into limit x tends to infinity and y by x tends to m1 f n minus 2 by q n minus 2 plus limit, same limit. Okay, limit x tends to infinity y by sorry let me plus limit x tends to infinity y by x tends to m1. Okay, r n minus 2 divided by q n minus 2, and this equals to 0. Okay, now this is a quadratic equation in C1. Okay, so in C1, so C1 will have two roots, so C1 root have two roots. Let the roots be C1 dashed and C2 dashed, and that can be determined from this equation. Okay, so we are getting y is equal to m1 x1 plus c1 dashed and y is equal to m1 x1 plus c2 dashed. So these two are the asymptotics. Similarly, we can go to the, so these two cases can arise. Okay, so from a general equation, so we are getting the asymptotes. So what is our task to do? So this is our highest degree term. Okay, remember this fact. And highest degree term, so we are making this highest degree term to 0. Understood? So we shall apply this first highest degree term, make it 0, and from that equation you will get some, and y by x, replace y by x by m. So we are getting some equation involving m, and we will get m1, m2, m3, mn, so on. Okay, so one example, let me show an example in the next page. Okay, go to the next page. Let the our equation of the curve be like this: x square into x square minus y square into x minus y plus 2x cube into x minus y minus 4y cube equals to 0. This is our equation. So what is the highest degree term here? P5. See here, x to the power 4 and here x, so x to the power 5. Okay, so P5 will be the highest degree term, Pn. And what is that term? X square into x square minus y square into x minus y. Okay, and this can be written as x square into x minus y whole square into x plus y. Okay, so you have to take highest degree term. Now the highest degree power in y, highest degree power of y, remember this fact, our equation was in the form of y to the power n. So what is the highest degree power of, here y square and here y, so y cube. So y cube is the highest power of y. So highest power of y is y cube. Okay, so let's find out. And coefficient of y cube is, coefficient of y cube is x square minus 4. So highest power of y in P5 is y cube, and coefficient of y cube is x square minus 4. Got it? So I am showing it you again. Pn, here is the xn and this is the y by x term. So highest degree power is xn and this one. Okay, and here Pn, so here you see Pn, highest degree term is yn. Okay, so we make coefficient of y x square 4 and make this equals to 0. So x square minus 4 equals to 0. This gives you x is equal to plus minus 2. So these two are in the form of y is equal to, these two are asymptotes. Now asymptotes parallel to x axis, parallel to y axis is given by x term only. So by making phi m equals to 0, we are getting this one. Okay, again you see x plus y, so this is, these two asymptotes are parallel to y axis. Okay, again another one is that x plus y equals to 0 and x minus y equals to 0. They are straight lines through the, they are straight lines through the origin. Okay, and parallel to the asymptotes. They are straight lines through the origin and parallel. X plus y is a straight line passing through the origin. So let our, but parallel to the, passing through the origin, but our asymptotes may or may not pass through the origin. So let the asymptotes becomes x plus y is equal to c1 and x minus y is equal to c2. So what is c1? c1 is equal to limit x tends to infinity and y by x tends to how much here? Y by x, y by x, can anyone tell? C1 is equal to how much? Minus 1. From here y by x is minus 1 and C2 is equal to limit x tends to infinity, y by x tends to 1. Okay, bracket y minus x, bracket y plus x. Hence y plus x and y minus x. So c1 is equal to limit x tends to infinity, y by x tends to minus 1. Now what is x plus y? What is x plus y? It is nothing but 4y cube minus 2x cube x minus y divided by x square into x minus y whole square. From here you find it out. From this equation you find it out what is x minus y and what is x plus y from this equation. Okay, so just take this. So this is equals to minus 1. If you carry out this, it will be equal to minus 1. That is your task, you do it. Okay, and from this equation here you have to put x plus y. This is x plus y. Here you have to put y minus x. So from that equation you find out y minus x and take this, find out, and you will find that c2 is equal to 1. Okay, the result will be c2 is equal to, there will be two values, 2 and minus 1. Okay, so this equation, if you put y minus x from this equation here and take this limit, you will get two values of c2. Two values of c2 you will get. So this will be this is the first one and this is the second one. So this is this is case 1, or most probably this is case 1 and this is case 2, because you see here there is a repetitive factor. This is 1 is the repetitive factor. Okay, but x plus y is not repetitive. So this is case 1, x plus y is case 1, so c1 will come out, and x minus y or y minus x, there is a repetitive factor, so c2 will have 2 value in our previous. It is missing, it has gone. So remember this fact. Okay, this one is non-repetitive, so c1 will come here, and this one is repetitive factor, so c2 will come here. So for non-repetitive c1 and for repetitive c2, so there will be two values of c2. So there will all the asymptotes is given by, so first asymptote is 2 asymptotes, and this is the third one, and this fourth one and fifth one, and you have to find out the equations also. So equations are these two are equations. Another equation is y minus x is equals to 2 and y minus x is equal to minus 1. Okay, and x plus y is equal to minus 1. So, and these two 3, 4, 5. 5 asymptotes. Okay. So this is our asymptotes. I will send you the whole thing by WhatsApp tomorrow, day after tomorrow. The whole thing you will get it. Okay. So this is our. If there is any problem, you can ask me now. If there is any problem, you can ask me now. Hello. Hello. Can you hear me?
Yes, sir. Yes, sir.
Hello.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Is there any problem?
No, sir.
No, sir. May I ask you some questions? Who are you speaking? Tell me your name.
Yes, sir. Sir, Dupchen.
Dupchain. Okay. This is the most general theory. Have you understood it?
Yes, sir.
Is there any problem? Just now I am
So,
going
no,
to.
sir. So, my network is
That is a common problem. Okay.
kind of. Yes, sir. Yes, sir.
What happened?
So, my network is kind of bad, sir. That's fine.
Okay. Anyone else? Anyone else? Ridhiraj, are you present?
Sir.
তুমি তুমি আছো নেটওয়ার্কে না নেই?
Yes, sir.
তুমি অঙ্কটা ঢুকেছো?
The screenshot নিয়েছি।
স্ক্রিনশট নিয়ে রেখে দিয়েছো? আমি তো
Yes, sir.
অঙ্কটা করিয়েছি। থিওরিটা করানোর পরে একটা অঙ্ক করিয়েছি। দ্যাট ইজ দ্য এন্ড। এই থিওরিটা করলে আর অন্য কিছু করতে হবে না, এখান থেকে সব কটা অঙ্ক করা যাবে। চন্দনা রায়, আর ইউ প্রেজেন্ট?
স্যার ছন্দা রয়।
ছন্দা প্রেজেন্ট। তুমি তুমি অঙ্কটা ঠুকেছো?
হ্যাঁ স্যার, আমি সমস্ত ঢুকেছি।
আচ্ছা, কোনো জায়গায় অসুবিধা আছে?
স্যার বলছিলাম যে আপনি এক জায়গায় কোথায় লিখলেন না আর, মানে যেটা
হ্যাঁ, আর।
অঙ্ক এক্সাম্পল দেওয়ার আগে।
হ্যাঁ হ্যাঁ, আর 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 এন মাইনাস টু লিখেছি।
হ্যাঁ স্যার, ওর সামনে কি নট ইকুয়ালস টু আছে?
নট ইকুয়ালস টু, হ্যাঁ, না না, নট ইকুয়ালস টু নেই, ইকুয়ালস টু জিরো, আর এন মাইনাস টু। তাহলে টার্মটা হচ্ছে ওয়াই মাইনাস এম ওয়ান এক্স হোল স্কোয়ার কিউ এন মাইনাস টু প্লাস ওয়াই মাইনাস এম ওয়ান এক্স এফ এন মাইনাস টু প্লাস আর এন মাইনাস টু ইকুয়ালস টু জিরো।
হ্যাঁ স্যার, তাহলে ঠিক আছে।
ঠিক আছে, ইকুয়ালস টু জিরোই তো
হ্যাঁ
হবে,
স্যার।
কারণ ইকুয়েশনটা আসছে। আমি এর মধ্যেই এখনই পাঠিয়ে দেবো পুরো থিওরিটা তোমার হোয়াটসঅ্যাপে ইয়ে করে। এখান থেকে তুমি যেটুকু কারেক্ট করার করে নিও। ঠিক আছে। প্রথমত কেস
হ্যাঁ
ওয়ানের
স্যার।
মধ্যে হচ্ছে যদি একটা ফ্যাক্টর রিপিটেটিভ থাকে তাহলে দ্যাট ইজ কেস ওয়ান, আর যদি রিপিটেটিভ না থাকে তাহলে সি ওয়ান আসবে, আর যদি রিপিটেটিভ থাকে তাহলে সি টু আসবে, সি টু দুটো ভ্যালু আসবে। তেমনি যদি তিনটে হয় তাহলে সি থ্রি আসবে, সেখানে সি থ্রির তিনটে ভ্যালু আসবে। এরকম করে করে চলতে থাকবে। বুঝতে পারলে? সাধারণত তোমাদের দুটো এই আমি একটা অঙ্ক যেরকম করলাম এরকম অঙ্কই পরীক্ষায় আসে, সুতরাং এর বাইরে চিন্তা করার খুব একটা স্কোপ নেই। আমি পাঠিয়ে দিচ্ছি, এটা আমি তোমাদের এখনই পাঠিয়ে দিচ্ছি। রাহুল শাহ, আর ইউ ইন দ্যাট?
Yes, sir.
হ্যাভ ইউ রিটেন ডাউন দ্য সাম?
Yes, sir.
Nikita Kanu, have you written it?
Yes, sir. Yes, sir.
Raju Das, have you written it?
Yes.
Okay. So just wait, I am sending it just now by check your WhatsApp book. Okay.
Okay, sir.
Okay. I am sending it this sum as well as the whole theory. Okay. And this whole theory, if you understand it, you can attempt any sum of these asymptotes. There is no need to read anything more. Okay. So what you will did, first you will did that what you have taught, that make the highest degree term. Now in the C, in the beginning I have shown it that in the beginning there is a term like this. Here I have taken x to the power n common. Okay. You can easily take y to the power n common. So here will be x by y. So no problem is there. Okay. You will get the same result. Understood? The meaning of this is that you have to make this phi m equals to 0 and y by m is equal to y by x. In that case it will be x by y. So understood? And this one, that means you have to find out the highest degree term, coefficient of the highest degree term, coefficient of the highest degree term. Coefficient here is the highest degree term, this is the coefficient. So make that equals to 0. Make that equals to 0 and you will get the asymptotes one after another. That's why it has been taught that make the highest degree term equals to 0. Instead of this, you will get y to the power n phi n x by y. So nothing happens if you change x to y or y to x. Nothing happens. Make the highest degree term equals to 0 and then find out the rest. So what I did in the sum, I did in the sum in the next same one. I make this highest degree term, and here I have taken y cube. You can take x's. What is the highest degree? X to the power 5. So you can make the coefficient of the highest degree term x to the power 5 equals to 0. You will get the value of y. Here you will get the value of x square minus 4, because y cube I have taken highest degree, its coefficient is this. So make this terms 0. You will get first one. But here in this equation, here this is a repetitive factor and this is a non-repetitive factor. So C1 will come here and C2 will have two values according to the theory. Okay. So I am just sending you. Okay. Then I am leaving it. Thank you very much. And just stop recording first. Stop recording.